In this video, the experiment number 12 is performed. You will use information in this video for writing a report. It is about the centripetal force. The objective of this experiment is to understand the centripetal force. This kind of force is found in daily activity. Many rides in amusement parks directly involve the centripetal force. In this experiment, we consider two scenarios, A and B. In scenario A, the gravitational force acts on the object with the mass marked with lowercase letter m. The magnitude of this force is equal to the tension force in the string, since the mass m is not moving. It is also equal to the spring force because the bob is not moving. Therefore, the magnitude of the spring force is mg. Next, we consider the scenario B. We take the mass with lowercase letter m out and use our hand to spin the pole. We spin it fast enough so the spring extends and shares the same length as the one in scenario A. Since the bob is moving in circle and it's only the spring force that is horizontal, the spring force is the centripetal force. The formula for calculating the centripetal force is shown here. F is the frequency of the rotation. This capital M is the mass of the bob. R is the radius of the rotation. This R is also the distance from the bob to the pole in scenario A. Therefore, the spring force in both scenarios are the same. The centripetal force must also be equal to mg from scenario A. In order to calculate forces we need in this experiment, we need the following information. The first one is the mass of the bob we use, which is 367.09 grams. The next one is the mass of the hook that we use, it is 49.28 grams. And the disc with 100 grams each. There are 4 parts in this experiment. Part 1. The mass with lowercase m is the mass of the hook plus the mass of a disc. The mass with the capital M is the mass of the bob. In part 2, we change only the mass with the capital M to be the mass of the bob plus the mass of one disc. In part 3, we change the mass with the lowercase m to be the mass of the hook plus the mass of 2 discs, but the mass with the capital M is just the mass of the bob. In part 4, we use this mass with lowercase m as same as the one we used in part 3, but the mass with the capital M is now the sum of the mass of the bob and the mass of one disc. Part 1. In scenario A, we use a hook and a disc together as the mass with lowercase m right here, and record the gravitational force which is mg, and you record it as computed force. Use the acceleration by gravity equal to 9.81 meter per square second. Then you record the mass of the bulb. This capital M, this is the bulb. Then move or adjust the horizontal bar, this one. So the force from the bar does not contribute to the horizontal forces. Move the pointer here until it is right under the bulb. Then you measure the distance between the bulb and the pole by reading the location of the pointer. Use this picture below, this one, to estimate the radius of circle, which is also the distance between the bulb and the pole. You may locate the position of two edges and then say that the radius is the sum of these two locations divided by 2. In scenario B, also in part 1, use a hand to spin the pole. While spinning the pole, try to keep the bulb at the pointer. Watch the video. Count the number of cycles from the moment that the stopwatch starts running to the moment that the stopwatch stops running. Watch the video. Once you finish watching the video, record the number of cycles. Record the total time from the figure, this figure, and calculate the frequency. The frequency is the number of cycles divided by the total time. And now you calculate the measure force using the formula, and also calculate the percentage difference by using this formula. Next, part 2. You add one more disc on the bulb. This mass with capital M here must include the mass of the disc right on top. Use a hand to spin the pole. And again, while spinning the pole, try to keep the bulb at the pointer. Watch the video, count the number of cycles from the moment that the stopwatch starts running to the moment that the stopwatch stops running. Watch the video. When you finish, again, you will record the number of cycles, record the total time from this figure, and calculate the frequency from this formula, and calculate the measure force by using this formula, and also calculate the percentage difference by using this formula. Next, part 3. Scenario A. Take the disc out of the bulb. So now the mass of the bulb is the mass with capital M. Add one more disc on the hook. Therefore now the mass with lowercase m is the sum of the mass of the hook and the mass of two discs. Record this new mg as the computed force. Move adjust horizontal bar until the force from the bar does not contribute to the horizontal force. Move the pointer until it is right under the bulb. Record the radius of circle by using this picture, and again, you may just find the location on the left and the right, and then sum them up and divide it by 2. That is your radius. And take the mass with lowercase m out. Use the hand to spin the pole. Again, while spinning the pole, try to keep the bulb at the measuring stick of this pointer P. Watch the video, count the number of cycles from the moment that the stopwatch starts to the moment that the stopwatch stops. Record the number of cycles, record the time, find the frequency. Calculate the measure force, which is the centripetal force, using this formula, and also calculate the percentage difference. The last part is just to add one more disc on the bulb here. So the mass m must include the mass of the disc. Use your hand to spin a pole, spinning it, and try to keep the bulb right at the pointer. Watch the video and again count the number of cycles from the moment that the stopwatch starts to the moment that it ends. Record the number of cycles and also record the total time from the picture. Calculate the frequency. Calculate the centripetal force from this part 4 and calculate the percentage difference by using this formula again. Then you will show your calculations. You must show one example on how to get each following quantity. There are frequency, computed force, measured force, and percentage difference. After that, you will give some discussions and finally give the conclusion. Thank you.